I'm CK. Tonight we've got another kit from Velleman. I've been doing a lot of their kits lately. They're good quality and I think young people will learn a lot from them, so I want to keep doing them. This one is Rolling Message, a little digital display that I assume scrolls as it operates. So we'll put it together and see how much fun it is. Hope you enjoy the video. And here's the box. Rolling message board. It's probably not programmable, but we'll see. LED, that's the focus. Soldering level 2, so that means it's probably pretty simple. Oh, you can create and display your own moving messages. Maximum 18 or 16 characters. Adjustable scrolling speed, onboard controls push button, and then you need a 9 to 12 volt DC adapter or a car battery power supply, not included, and a 9 volt backup battery, I assume that is, to keep your message around. Looks like a bunch of LEDs, bunch of resistors, and some other stuff. We'll look at it. And let's open her up and see what the bits and pieces look like. Here's the 9 volt battery holder, which I'm going to assume, based on other things, they're going to use it as a stand also. But we'll see. I'm not going to get ahead of myself any more than I usually do. Look at the piece of paper that comes with. You generally don't need to look at their build guides online, even though we'll see if this has a schematic. Yeah, they do. They want the battery holder on the back to hold it upright, which is fine. Oh, there's some jumpers. Got to put in some jumpers. I wonder why. Huh. Then some resistors, diodes, capacitors, LEDs, voltage regulator, a trimmer probably for speed, push buttons to do your programming, and the IC. This is a programmed PIC 16C58 controller. Then a power jack, battery holder, and a cover for the display. Oh, you got to get your own glue. I actually am going to go online and see if it does have a schematic available, because I prefer kits with schematics available so youngsters can see how current flow is and see what current and control flows are. Dump all the bits out, making sure they're all out of the bag. Here's the display cover, which is also red, which is interesting. Bunch of resistors now. Oh, I see. There's a bunch of resistors and 4 of the 4148 diodes, and the resistors are not all the same value, so they just put the different value resistors on the same strip. These look like, what are these, 0 or 10 ohm? No, they're 0 ohm, I thought so. Interesting. They're just, I mean, I don't know why they're using 0 ohm resistors when they're also using jumper wires at the same point. Maybe as fusible links? I don't know. I don't know why they put that in there. And here, yeah, Velleman is the only company I know that actually does that. When you're going to have jumpers, they include just bare lead wire instead of having you just simply use some cutoff leads when you're putting the other resistors on the board. Little disc cap, and that's a 22 pico. There's our trimmer. There's our voltage regulator. It's a LO5, so 5 volt. Socket. Here's the chip, and it's got a little marker stripe on it indicating that it has been programmed. Oh, that's interesting. It doesn't actually give you directions on how to program it. That's interesting. So I guess you're going to have to go online to see that. And these caps are 47 microfarad, 25 volts. Both of them are the same, and a couple of screws to put the battery box on. Another little cap. This is probably a 104, is it not? No, it's not. It's, what is that one? Yeah, it's a 104, I was right. Decoupling cap for the chip. And then switches, tactile switches, and a little knob to go into this so you can turn it better. And we've got all little LEDs. This package has little perforations, which means it's easy to tear open. Ha! I bet I can't do it. Oh, of course I cannot do it. Oh, there we go. I did it. Yay, me! I'll put these in a different bin. So that's all the bits and pieces. I'll get the soldering iron heated up, find the build guide to see if it has programming instructions, and we'll put this thing together. So I followed the QR code to find the online manual so we can get rid of the box now, get it ready for recycling. Unfortunately, all it has is a PDF of this. So no additional information, no schematic, and no programming instructions. So we're going to have to rely on the button descriptions. This button says set. This button says run, standby, or up and down. So I'm going to make a really unfounded assumption, but based on whatever experience. This is to run, turn it on, turn it off, and to change the letters, I guess you're going to hold down switch 1 and go click up and down. Again, I don't know that for sure because they don't give you any information about that, which is unfortunate. If you're getting this for a youngster, I would, I don't know if I would, given that the youngster won't know how to program it once they get it put together, which kind of defeats the purpose, doesn't it? So let's put our jumpers on first. I'm going to solder those 3 right now. Get a feel for the way the board takes solder. Again, this is pretty inexpensive circuit board. It's just fine, but it's just not. There we go. Taking solder just fine. Be careful, because these jumpers are directly connected to the other solder pads, and that's fine. The only thing you have to be careful of is while you're soldering this lead, you don't let the solder bleed over and clog up the holes that they're connected to, because since there's no green materials or solder resist between them, solder can flow across the copper plating, and then you'll fill in the hole, and when you try and put that component in, you'll say, oh my gosh, the hole is all blocked up. Oh no, it sounds like my water heater's going to come on. I hear it clicking, getting ready to start up, so when the water heater comes on, I'm going to go ahead and do, there it goes. I'm going to do the resistors, finish this other jumper, do the resistors, and there's not much to talk about there, so I'll turn the volume down on playback and enjoy resistor time. Water heater's off, resistors are on. So next will be our diodes, 4148's high-speed switching diodes. And we want to make sure we get the polarity right, of course. So the black line on the diode will go to the white line on the circuit board. And you don't want to bend the leads right up against the body on the diodes because the diodes are kind of small. Put 1 or 2 millimeters of lead to the side of each so they fit well. See, I bent that one a little too close. Just a hair. Not a big deal, it's just how much you want to fight with it to get it into the circuit board. And I think I'll put the caps on while I'm here. The 22, I picked up the 22 first. And as always, I just cut them out of the paper tape. No need to fight. Now the 104 decoupling cap, which should be right by the integrated circuit, because that's where, if you get a bunch of 104s, a bunch of 100 nanofarad or 1/10 of a microfarad capacitors in a kit, you just say to yourself, well, if I've got a bunch of 104s, and they can be blue or amber or whatever, if I've got a bunch of 104s, I should probably look near my integrated circuits for their location, because that's where they usually are. For power smoothing, power filtering, power whatever, they're decoupling from power glitches. So we're going to lay all the capacitors down, the electrolytics down like this, flat on the board. And long leg goes on the positive side. And the holes are very clearly marked with plus and minus, so you can do that without any hesitation. Now I'm going to solder these guys on the board. Now all the LEDs. And this board does not have positive and negative markings for or symbols. It doesn't have a plus or a minus sign. However, if you look closely, the shaded side has a flat edge, and that's where the short lead, the negative lead, the cathode side goes. So just be careful, because when you're putting whenever you're working with this many similar parts, you can lull yourself into complacency, for lack of a better term, on getting them all correctly installed, and you'll slip, mind will wander. I'm fussing with this one because these don't actually sit flat. They don't sit flat. That's too bad. So again, for each one, say, okay, do I have the short lead in the shaded side? Do I have the short lead in, oops, do I have the short lead jumping out? Do I have the short lead in the shaded side? And so on. Don't just be humming along, sticking diodes in and not thinking about it. And they gave us 2 extra diodes, LEDs, just in case any of them turn out wrong. So I'm going to put a little index card there, put them all down like so. And what I'm going to be doing now is I'm going to solder one leg of each, and then we'll go back and flatten them out as if they're not completely flat to the board. Actually, I just changed my mind. These are so tightly packed, I can't actually do that. So I'm going to take a look and see it. See, these came out all wiggly woggly, so I'm going to just do them right now. Heat up that one lead that I did, bring them flat onto the board. I'm going to trim off the leads I just soldered, and then do the other lead on that LED. And I'll be doing that for all these, so that'll take a little while. All the LEDs are on, so that's nice. Not too hard, just tedious, and again, make sure you check the polarity on every single one you put in. Now I'm putting the voltage regulator in. It looks like a transistor and is very similar to a transistor, but it's a voltage regulator and it's got a flat spot, as they do. And we'll put the speed control in. Actually, that doesn't fit too snugly, so I'm going to solder one leg on there right now so it doesn't fall out while I'm placing the other components. And then the tack switches, push buttons, there are 3 of them. Hard to get them wrong because they're not square, they're rectangular. So unless you force them, they only go in one way. And then I'm going to put the IC socket on. And the notch is on that end, and the notch is there on the circuit board. And I'm going to rest it on my pinky finger from behind to keep it on the board while I solder one leg. One leg's done. Now take a look at it, and it's not quite flat. I don't know if you could see that or not, but it's not quite flat, so I heat the solder ball up, push it flat with my index finger behind the board, and it's all good. And I'm going to go ahead and put the power connector on also while I'm here. Just get all the soldering done all at once. Now this is an area where on the power connector I'm going to go a little bigger on the solder dimensions, and I'm going to put a lot of solder on those connections, because the solder is what takes the force of you connecting and disconnecting the power supply. So that's that. Now I'll solder up all the other connections I've got left on the board. This diagram indicates that you want to get some solder from J4 onto that pin on the back of the connector. Is that right? Is that really what you want? That sure is what that looks like. So it'll either be right or it won't work. Go ahead and put it on there to see. Kind of makes sense, because earlier when I was looking at the way that connector, that jumper worked, it didn't seem to make sense. But now it does. Now we'll put the battery box on the back. Trying to figure out how we go. Okay, we go this way. Trying to get the battery leads to go in a good way so they don't interfere. So taking them out the bottom seems good. We go through the front here. Now I can snug these down. Don't tighten them a whole ton, because it's just going into plastic and you could strip it pretty easily if you get too aggressive. Just enough so it doesn't move. The fact that it's going into plastic also makes sure that it's not going to flip around a lot. Now we're going to put the battery, the backup battery wires on these two copper pads on the back, and the way we'll do that is I'll put a bunch of solder on each pad. Then get a pair of needle nose and hold the wire kind of somehow. Might have been better had I gone out the side instead of out the bottom, but I didn't know. Hold the wire on top of that little solder pad I just made. Heat it all up. Have my needle nose slip away, heat it all up. Put the wire in there, let it cool. Wire is firmly attached. Do the same for the positive side. I may just hold that with my fingers. See how much I can burn myself. See how much I can't get it in place. And there we go. No more soldering to do, so the soldering iron gets turned off so I don't forget and come out tomorrow morning and find that I left it on all night. Not that that's happened more than 5 or 6 times. So we'll put the programmed microcontroller in. Get the legs a little straight against the side of my bench, even though I think I did a little too much there, so I'll straighten them all back out a little bit. And notch goes to notch. And even though I put the socket on right, I always look at the marking on the circuit board, because that's the truth. The socket may lie to you. I'm going to put my little knob in there, speed knob in there. And now, I think we're ready to do something with this. Let me turn this light off, even though the cameras compensate so much that rarely actually works. And I'm going to put the backup battery in. Oh, this battery box is not very good. In fact, I'm not going to use the backup battery, because I don't want to force it in there. Let's see, what do we need? We need 9 to 12 volt DC, and see what I've got plugged in right here, right now. I've got 12 volt DC, half amp. That should work. Let's plug it in, see what happens. Nothing. You maybe really want the battery in there, don't you? Or that diagram in the... No, it says solder. Okay. So maybe it really does want that backup battery in there to work. But failing that, I'm also going to check my power supply to make sure I'm not, not working with a bad power supply. Nope, get 12 volts or 11.8 volts out of that. So let me try and force this battery in here. Okay, so with the battery in, as you can see, it's doing something. No make it run. Oh, those are the letters, see? Okay. It's an S, R, some Q, I guess, P, O. So I don't know how to... See, we're going through all the letters. That's a question mark, kind of double exclamation point, a period, colon. So it's got 2, T, V. It's got everything you need. There's a T, but again, I don't know how to make it run. We had it running. But now it doesn't want to. Maybe if I press and hold this one. Nope. There we go. There's an arrow. I love something. Let me do one more thing. Maybe this filter piece will help. Well, that condenser's in the way. I'm sorry, capacitor is in the way of that. Let me slow the speed down again. There's the arrow. I love... I love lamp. Okay. Again, I still don't know how to equals 3. Now let's see if I can get that to run. See, I don't know. Sorry, this is not intuitive enough for me to figure out. Maybe it does that? No. Equals 3, so I programmed that. I'm going to select here, put that arrowhead, and then I did the 3, and then I think I can change the I. Okay, so that's K. Let me change it to something else. See, we're cycling through everything. E, F, G, H, I, K. Go backwards maybe. Okay, so you kind of hope you can see what I'm doing. I'm pressing the set button and the up and down arrow buttons to kiss. Now we can put an underscore there, or a blank underscore, and now that looks kind of like an M. And then we'll make that an E. And then I'm going to make this a blank again, or what passes for a blank, an underscore. I'm sure there's a blank in here, I just can't. I'm not patient enough to try and... There's a blank. Blank. So it's a little tedious to program, obviously. Okay, now we've got 3, kiss, F, dots. Now it's circling around to the beginning. Arrow, arrow, kiss. Turn the speed all the way up. Let's see how fast it goes. Oh, pretty smooth. It's pretty smooth. Actually, fast is better. 3, kiss. So that's it. It's not a bad little thing. The programming is a little finicky, and I'm going to write to Velleman and say, you really need to put instructions on how to program this, because if a child is doing this, it's going to be very frustrating. But overall, a fine little kit. As you saw, relatively quick to put together. A lot of LEDs to put on, but that's good practice. And I hope you enjoyed the video.